be seated. Good evening, ladies and gentlemen. I'm Wynand Steyn. I am the Dean of the Faculty of Engineering, Built Environment and Information Technology. And it's my pleasure to welcome all of you tonight. And very specifically, Prof Loretta Ferris, our Vice Principal Academic at the University, who officiates tonight. Then, obviously, our speaker, Prof Hannes Gräbe. Really welcome good to have you here. Members of the UP Executive, my fellow deans and deputy deans that are here, heads of departments, academic and professional staff, colleagues, also very specifically, and I want to mention it, colleagues from other faculties. It's wonderful to have you here, because I think it's one of the whole ideas of the inaugural lectures to actually have the transdisciplinary type of discussions and seeing what other faculties are doing. Then very specifically also the family of Prof Gräbe, the ones that's in the country. And it's wonderful to have you guys over here, because those are the people that's all the support. Welcome to you. Ladies and gentlemen, it's always good to have these inaugural lectures. It's always good for us to show colleagues, friends, family, what our esteemed professors are busy with. So tonight's lecture is titled Tracks of Discovery, Innovation and Education, Inspiring a New Future for Railway Engineering. And I would like to ask Prof Ferris to officially open this inaugural lecture.
Good evening and welcome to this inaugural lecture. I would also like to acknowledge our speaker, Professor Gräbe, any members of the University Exec and Senior Management that may be here, the Dean of the Faculty of Engineering, Professor Wynand Steyn, the Deputy Deans, Professor van der Merwe and Professor Meiner, HODs from the faculty and other faculties, as well as colleagues from EBIT and other faculties, any students that may be here, all guests that are present here this evening. And then a special word of welcome to Professor Gräbe's family and friends, in particular his parents, Petro and Ida Gräbe, and of course Professor Gräbe's dad was a UP employment in maths for his entire career and also served as the conductor of Tax Camerata, so welcome back. His wife Dalvanisa, and then his children who unfortunately are not able to join us here this evening. And then he also wanted very specifically to welcome his personal friends who are able to attend this event this evening. So I'm really honored to welcome you this evening on behalf of the University of Pretoria to this inaugural lecture, which is titled Tracks of Discovery, Innovation in Education, Inspiring a New Future for Railway Engineering. The University of Pretoria is known for its tradition of academic excellence and its commitment to fostering a nurturing environment for both teaching and research. Here at UP, we drive innovation, we nurture groundbreaking research, and we also strive for transformative learning experiences. And so a professorial inaugural lecture is a moment when we focus on the accomplishments of the inaugural lecturer and their contribution to the strategic intent of the university. And so as we convene to listen to the words of our distinguished lecturer this evening, we also simultaneously, of course, witness the birth of a fresh academic discourse. We are reminded that this institution is more than bricks and mortar. It's a sanctuary for the cultivation of the minds and the pursuit of knowledge. It's a place where curiosity meets discovery, where diversity fuels creativity, and where the torch of wisdom is passed from one generation to the next. The inaugural lecture also represents an academic rite of passage, a moment when a scholar takes center stage to share their expertise, their passion, as well as their vision with the academic community and beyond. And this notion of sharing beyond the academic community is, by the way, not an easy endeavor. For as much as we are used to sharing our new ideas with our students or with our peers, it's not always easy to actually share your ideas with those who are outside of your discipline. And so an inaugural lecture requires what I call a discourse of inclusion, one that will leave us, the non-civil engineers, as engaged as the civil engineers in this room. I always say that the inaugural lecture needs to appeal both to your colleagues and to your mother. This of course makes the inaugural lecture quite unique. So in keeping with custom, I would now like to formally introduce Professor Gräbe. He's a full professor as well as head of Department of Civil Engineering in the Faculty of Engineering here at UP. He holds the chair in Railway Safety, which is sponsored by the Railway Safety Regulator since 2016, and previously the chair in Railway Engineering, sponsored by Transnet Freight Rail. Professor Gräbe's research focuses on the behavior of railway foundation materials subjected to cycling loading and the characterization of track component performance and behavior through field and laboratory experimentation. He combines his experience in track technology, geotechnology, and advanced laboratory testing for the development of novel condition monitoring techniques, maintaining models, and numerical analysis of track structures. This includes a new research focus on the instrumentation of railway formations for unsaturated soil behavior studies. His research finds application in the improvement of rail transport on the Transnet, Gautrain, and PRASA rail networks. Most recently, he has been successful in obtaining funding under the NRF National Equipment Program through collaboration with colleagues in the departments of Civil, Mechanical, and Industrial Engineering for the developing of a unique research vehicle that is equipped to carry out cutting-edge condition monitoring on the road and rail infrastructure. During the last 5 years, Professor Gräbe served on the Transnet Freight Rail School of the Rail Advisory Board and is a founding and board member of the South African Heavy Haul Association. Internationally, he served on the Railinium Scientific and Strategic Committee, an advisory board that oversees industry and government-funded research projects carried out in Europe by various universities. His international collaboration stretches from African countries such as Ghana and Tanzania to France, the UK, and the USA. He has received Best Paper Awards in Railway Engineering from the South African Institution of Civil Engineering, as well as the Psyche Geotechnical Division, where he received the Jennings Award for the Best Geotechnical Paper. During 2019, he delivered the 6th Stephen Marrick annual lecture in Railway Engineering in Australia. Following this event, he was invited to become an IRT Rail Research Associate at Monash University. He's of course registered with EXA as a professional engineer. He's also a fellow of both the South African Institute of Civil Engineering and the South African Academy of Engineers, and a B-rated NRF researcher. But of course, he's more than a professor. His hobbies include playing the piano, and he's part of his church worship ministry. He loves the outdoors, bushveld and camping, and his favorite holiday destinations are the Kruger National Park and the Drakensberg. In his own words, being in one of these places with my wife and children is heaven on earth for me. I now invite Professor Gräbe to deliver his inaugural lecture.
Good evening, Prof. Ferris, Prof. Wynand-Steyn, other deans and deputy deans, heads of departments, academic, professional staff and colleagues, family members and friends, ladies and gentlemen. It is an honor for me to deliver my inaugural address as Professor in Civil Engineering at the University of Pretoria this evening, especially in your company. Tracks of Discovery signifies a path of continuous exploration, creativity, and learning in the field of railway engineering. Innovation highlights the pursuit of new knowledge and insights and the development and application of novel ideas and technologies. Education underlies the vital role of education in shaping the next generation of railway engineers. As a whole, the title conveys the idea that through a combination of discovery, innovation, and education, the field of railway engineering is set to witness remarkable progress and advancements in the coming years, inspiring the future of the industry. This evening I want to take you on a journey of 30 years from the day I graduated with a B.Eng in Civil Engineering from this university to the present day, demonstrating how my career in railways developed as my days were directed, shaped and influenced by many people and organizations. Excuse me. I want to introduce this address with a photograph I captured at the twilight of a day on the South African coal line, south of Vryheid. In English, every ending marks a new beginning. Just as the sun sets, it simultaneously gives birth to the promise of a new dawn. This philosophy has resonated throughout my career. The end of each season has always heralded the start of something new. Every achievement, every goal met, merely signifies the beginning of a fresh challenge. In the same vein, this inauguration is not a destination or an arrival for me. It signifies the start of a new endeavor. Now, if my career started at the University of Pretoria, then the year it all started was actually 1970, the year of my birth. My parents, here with us tonight, were the first house parents of House Mupani, then resident in the beautiful building Roosmarijn, and I spent my first months on that balcony. In 1989, I chose engineering as a field of study, undecided between civil and mechanical engineering. On enrollment, PeopleSoft assigned civil to me, a kind of an arranged marriage, and I accepted. After graduation, I enrolled for a direct master's degree. Yes, it existed years ago, but I was lured into industry where I started my career as a spoor at Transnet in 1994. Due to this move, my master's took a few years longer, matching current, often debated statistics in our department. Through international collaboration of the Department of Civil Engineering, those days with a British professor, I was offered the opportunity to study towards a PhD in Southampton, England. Transnet graciously granted me paid leave for 3 years. We moved to England as a family of 4 and came back 3 years later as a family of 5. A few years later, I decided to establish a private consultancy called HG Specialist Track Engineer and concluded my 14 years with Transnet at the end of 2007. Now, although the consultancy initially thrived, it eventually dwindled similar to a neglected branch line or a forgotten railway track. This concludes the red track of my career. My formal academic career started in 2008 with the task of directing the chair in railway engineering sponsored by Transnet. A second 4-year agreement was signed in 2013. During this period, the faculty was approached by the railway safety regulator to establish a chair in railway safety. In 2019, I was honored with an NRF rating, and shortly after that, the RSR extended their collaboration with UP for another 4 years. I'm proud to say that I became a drone pilot in 2020. Proud not because of the aviator mystique attached to pilots, but because of the fact that I apparently did not play enough computer games as a kid, making the flying rather challenging and the achievement so much more. Nevertheless, taking to the skies added a sense of adventure to the life of an average railway professor. And that brings me to 2023 and this inauguration address. My career took a sharp turn to the left when I assumed the role of head of department. And that concludes the last 16 years of my career, the blue track. Moving on to an outline of my address, I will commence with some definitions to make sure we're all aligned on railway terminology, and I promise this will be the simplified version. Following that, I will delve into a detailed exploration of the 3 pivotal tracks: discovery, innovation, and education, each offering unique insights and perspectives. Finally, I will arrive at what I consider the cornerstone of our discussion, the important task of inspiring a transformative future for railway engineering. Railway terminology is surprisingly simple. It's the train on the track and the track on the terra, that is the soil or foundation. Then there's rail, sleepers, ballast, fasteners, sub-ballast, etc. But for tonight only, these are not for examination purposes. All 3 together is called the railroad, and according to a British gentleman, it is the chief of many mechanical devices, enabling us to get away from where we are to where we are no better off. For this purpose, the railroad is held in highest favor by the optimist, for it permits him to make the transit with great expedition. My journey of discovery started in the soil and focused on foundation behavior. Following naturally from this is the measurement of track foundation behavior. With these fundamental aspects firmly established, the logical next step is predicting the design life of the track. Moving upwards from the foundation, my focus shifted towards the track, where the innovation of smart track components and the characterization of track properties served as the building blocks for the digitalization of track monitoring. Finally, crossing over from the track to train, new fields of vehicle response measurement and vehicle dynamics paved the way for the optimization of track maintenance and performance. Let me then start with the first track, namely discovery. This track made me dig deeper into the terra, the foundation of the track structure. As with all things in life, the foundation determines the performance of the entire system and everything that is founded on it. It was therefore a good place to start. But as the father of soil mechanics noted, unfortunately, soils are made by nature and not by man, and the products of nature are always complex. Years ago, I documented classic formation failure on a heavy haul railway line in South Africa, captured in this video. This failure could stem from various factors such as inadequate construction methods, the use of substandard materials, overloading, insufficient drainage, or the absence of the crucial subballast formation layer. But here we need a much more fundamental and critical evaluation of soil particle behavior, subjected to not static, but cyclic and moving wheel loads. Finite element analysis unearths the fascinating phenomenon known as principal stress rotation. This occurrence is prevalent in situations involving moving wheel loads and extends beyond. Even my grandfather unknowingly demonstrated this concept while softening an orange for my siblings and me before feeding us with a big spoon like birds in a row. In essence, the rotation of the forces results in circular movement of the soil particles, simultaneously causing potential weakening of the soil due to alteration of the load paths and interparticle contacts. Exploring this phenomenon presents an experimental challenge, devising a method to introduce and induce principal stress rotation within a controlled laboratory environment. Predictably, engineers have simplified the intricacies of the complex loading just described by what is known as a cyclic triaxial test, where the major principal stress is cycled in a fixed direction on the left. This is already a significant achievement, but the simplification overlooks the rotation of principal stress and resembles a train that is merely bouncing up and down on the track. Fortunately, a sophisticated geotechnical instrument is available to investigate principal stress rotation, termed the hollow cylinder apparatus, in which an axial load and torque can be applied to the soil sample, like on the right. This brings me to my laboratories of discovery. At the University of Southampton, we developed a hollow cylinder apparatus in partnership with GDS Instruments. Now it was possible to test different types of materials under principal stress rotation. Gravel, sand, silt and clay could be proportioned to reconstitute soil samples representing those found in South African railway formations. Following the intensive laboratory experimentation in the hollow cylinder, back in South Africa, Transnet embarked on a substantial project of rebuilding failed track formations. We were granted unique opportunity to instrument such a newly constructed track formation and to monitor its long-term performance. Our research was therefore extended to a real-world test site on an operational railway line, introducing the complexities of weather, dynamic wheel loading and various external factors, including day-to-day maintenance. Continuous data capturing at the Blaubank test site enabled us to measure the permanent settlement and general behavior of the track from 2004 till the present day. I should acknowledge the skilled technicians who instrumented the track in such a way that the electronic devices, particularly the multi-depth deflectometers, are still functioning after almost 2 decades. The data set we obtained is therefore unique in the world, enabling us to validate the material properties employed in our analyses and simulations, as well as the design assumptions crucial for predicting the track's lifespan. A pivotal outcome of this study was the validation of our existing design methodology. This validation not only enhanced our confidence, but also solidified the credibility of hundreds of kilometers of new track constructed by Transnet during that period. Finally, the laboratory research abroad and the local field instrumentation on the coal-line enabled me to produce an updated version of the Transnet S410 earthwork specification, this time also with a foundation design for 30 tons per axle, an upgrade that was introduced on the Sishen-Saldanha railway line exporting coal at the turn of the century. In addition to this, detailed specifications were also produced for the use of geosynthetic products in all Transnet formation designs. And with this, I'm at the end of Tracks of Discovery, the red track of my career. Moving on to Tracks of Innovation. In this part, I will focus on the 2 rail components that are positioned above the track foundation. That is the track on the terra and the train on the track. This focus also signifies the blue track of my academic career at the University of Pretoria. Quoting a writer and philosopher, the only way of catching a train I've ever discovered is to miss the train before. Similarly, I want to emphasize that the only way we were able to produce innovative technologies was to miss a lot of others. While presenting the success stories, I'm omitting many failed attempts and dead ends. We do not innovate for the sake of innovation. In this field, like many others, there are good reasons why we strive towards smart railway monitoring and smart track components. Smart, by definition, implies analytics, feedback, adaptability, communication, and improved decision-making. This allows railway practitioners to manage and maintain. As you might know, without measurement, we cannot manage. Fortunately, an explosion in the development of optics, sensor technologies, communication protocols, artificial intelligence, and machine learning has given us an unparalleled opportunity to innovate in the field of track condition monitoring. Our first smart track component is called Clippy, a 3D printed exoskeleton or shell housing a minute battery-powered, Wi-Fi-enabled wireless microprocessor with onboard storage and high-frequency sampling. Clippy was developed based on the American Smart Rock, but quickly produced other original applications like Smavo, the smart avocado, and Smato, the smart tomato. These devices can record accelerations, rotations, and magnetic flux in 3 directions each, resulting in a 9 degrees of freedom smart sensor. The two videos illustrate the difference between remote video monitoring and inertial measurement using Clippy as applied to the measurement of track deflection as a result of dynamic train loading. The optical 2 degrees of freedom measurement on the left using a target and video recorder produces vertical and longitudinal deflection with time, while the 6 degrees of freedom inertial measurement with Clippy on the right reveals the complete 3-dimensional movement of the rail. The next smart track component is a 3D printed rail pad, instrumented with 2 accelerometers and a half-bridge strain gauge. The accelerometers are used to detect any wheel or rail irregularities, such as wheel flats, that create high impact forces. The strain gauge is used for load sensing and to measure the load transferred from the rail to the sleeper. The smart rail pad functions as a remote condition monitoring system with a microcontroller mounted to the rail that records the data from the strain gauge and accelerometers. It has an automatic triggering system that allows it to remotely measure railway traffic without human interaction or intervention, producing accurate wheel load results for weighing and impact detection. In another study, we used LiDAR, that is light detection and ranging, to identify and segment water leakage in railway tunnels. The LiDAR scanner can record in the region of 300,000 points per second and produces a point cloud in 3D with an indication of the intensity of the reflected light. The variance in the reflection of light from dry to wet surfaces enables us to track moisture and water leaks in the dark, inaccessible places, transferring the need for expert observation in hostile conditions to routine data analysis in the comfort of an air-conditioned office. The last track development originates from the research question whether track geometry can be derived from optical measurements instead of using conventional but costly geometry vehicles and inertial measurement systems. For this purpose and during COVID, experimental work could be conducted without the need to be on site. This research culminated in the development of 3 unique innovations, namely Spooroog for acquiring the photographic sequence of the rail, a low-cost centimeter-accurate geolocation service, or GPS, and Spoorpipe, the neural network pipeline that produces the 3D reconstruction of the rail profile. For this reconstruction, we were able to deduce track geometry with reasonable accuracy, comparable to conventional instrumentation. Parallel to the development of the smart track instrumentation, we carried out several track instrumentation projects to validate our new developments and to experiment with autonomous track structure monitoring. These included the instrumentation of a 300-meter long single concrete bridge deck over the Vaal River on the Ermelo-Majuba railway line. Then we had a moisture and suction measurement station on the Ermelo-Majuba track formation for investigation of unsaturated soil behavior and the resilience of track formations in the context of climate change, and a similar project on the coal line. Changing track now from the track to the train or vehicle in this case. At the beginning of this year, we embarked on a research project with a cross-disciplinary focus that includes aspects of railway engineering and ecology. Train-wildlife collisions on this line have negative consequences from a wildlife conservation perspective, as well as financial implications for the train operator. The aim of the research was to identify the contributing factors and provide guidelines as to how it can be managed to reduce future occurrences. I embraced this project because for the first time in my railway career, I was able to combine it with my love for game parks and the wild African bush. The University of Pretoria Road Rail Vehicle, RRV, acquired through the NRF National Equipment Program in 2019, was used for mapping the rail reserve and infrastructure assets along the length of the railway line in the game reserve. The survey was done at slow speed, that's about 10 kilometers per hour, to ensure a dense point cloud. The track geometry was measured and the resultant point cloud covered the railway assets and 20 to 50 meters on both sides of the railway line. For the first time since the development of the road rail vehicle, complete condition measurement was carried out this year by combining the following measurement systems. Firstly, the CRAB track geometry trolley, producing high accuracy track geometry parameters, the LiDAR system for 3D point cloud creation, our OXTS millimeter accuracy geolocation and inertial measurement system for exact positioning and alignment of all measurements, plus high accuracy vehicle dynamics. We also had a normal GoPro video recording in front of the vehicle, and lastly, dynamic vehicle response measurements from accelerometers installed on the body of the axles of the vehicle. A Mavic 2 Enterprise drone was used to create orthographic maps of specific hotspots locations on the railway line. Multiple photos with sufficient overlap were taken along the line to create this map. Following the orthographic mapping, the LiDAR data were used to identify animal crossings by calculating ballast depth variance. Similar to pedestrian crossings over a railway line, animals also disturb the ballast profile. This project is in progress and gained significant attention following unfortunate incidents where rhinos were tragically struck and killed by trains in KZN earlier this year. I want to conclude my tracks of innovation by pausing for a moment at the digital railway. As mentioned before, in 2019 I had the privilege of presenting the Stephen Marrick annual lecture in Melbourne, Australia. At that stage, the digital railway was still a futuristic concept, but the topic enabled me to think about what we do in our research. We were well on track to showcase smart track components and optical measurements, but I was challenged to also prioritize research in digital twins, virtual and augmented reality training, big data, and deep learning. In my quest to define the concept of the digital railway, I developed an acronym to encapsulate its core. Thus, digitalization transcends the mere application of digital technologies. At its heart, it revolves around people, making them central to the transformative concept. Our digital drive enabled us to design a real-time track condition monitoring system for the Gautrain that was installed in June 2022. This system comprises wired displacement and acceleration sensors and LoRaWAN, that is long-range wireless access network sensors, measuring temperature, acceleration and vertical deflection, all powered by solar. The low-Rawan measurement devices all have automatic triggers, allowing recording only during train passage, therefore resulting in remarkable 2 to 3 year battery life. The captured data is sent to a cloud-based dashboard, allowing real-time viewing of the results and the diagnostics of the system, such as sensor temperature, battery life, and door security. The dashboard can be viewed by different users with individualized permissions. In terms of the results, we have established new relationships between sleeper deflection and rail temperature, different for heating and cooling down regimes, and dependent on the track structure. The operator and maintainer have also benefited from the system, as sleeper deflection exceedances allowed them to identify flat or out of round wheels in the train fleet. Future development of the system includes change detection of the frequency spectrum response, aimed at the detection of long-term track structure deterioration. And that brings me to the end of tracks of innovation. In my last focus, tracks of education, I want to talk about postgraduate students in railway engineering and the role of a test track constructed on the UP Hillcrest campus. Here I want to quote Enterprises University of Pretoria, as we adopted this slogan as the motto for railway engineering short courses: train with us. They're poets and they didn't even know it. The University of Pretoria test track was constructed by our own students as part of their workshop practice training. We had some mechanized aid for compaction and track laying, but the earthworks and drainage were done by students. Probably one of the best examples of cheap labor, considering the fact that they even paid for this credit-bearing module. Nevertheless, this test track still plays a vital role in the third-year transportation engineering module, undergraduate and postgraduate research projects. One of our industry partners designed and constructed a special test track bogie capable of carrying 40 tons per axle, the highest axle load in the country. You can make a note of this for the first semester test and thank me later. After the official opening of the ballasted test track at our annual Railway Research and Training Review in 2014, another 2 test sections were constructed. Here you can see the slab track structure where rails are placed on a reinforced concrete slab with shoulders and fasteners cast into the concrete. On the right is the conventional ballasted track with our 40-ton per axle bogie, and on the left, tubular modular track, another ballastless track structure developed in South Africa. The 3 test tracks have since given our students an opportunity to see and experience a real track firsthand, and many research experiments are annually carried out here. My presentation focused on achievements, but a minor derailment 2 years ago was also part of the journey, fortunately without injury or loss of life. To the right, lo and behold, the meticulously restored track and vehicle. While perhaps 1 derailment per decade might suffice for RSR standards, rest assured we have no intention of repeating such an incident. I would like to spend a few moments talking about the postgraduate students I had the privilege of supervising since 2008, when I joined the university. Some of them are here today, and I consider them as probably the best academic investment I could ever make. Today, they are spread all over the world, and they are making a significant difference in the rail industry, from designing or building railway lines in England and Australia to managing an international rail service provider in America, not to mention those who are making a big difference in our own country. Today, I honor these students and also celebrate their research and current achievements. Most of them spend time with me in the field on a railway line, often from dawn to sunset, and somewhere along the tracks we became railway family with one goal: making railways work better for the common good. As I see them standing tall today and taking on the challenges ahead, I'm reminded that their qualifications were hard-earned and that those days in the sun are easily forgotten. Witnessing their transformation from students to professionals is truly rewarding. I had to add this slide to demonstrate the diversity in railway talent when it comes to postgraduate students. And here I blame the Department of Chemical Engineering for making this possible under controlled conditions in a UP laboratory. However, if I remember correctly, the actual railway research by these two students was on track till completion, and the craftily self-brewed rail pale ale did not derail their research, nor diverted them to a lucrative sideline spaza shop. I felt like writing a small tribute or poem to all previous and current railway students, but time was not on my side. So since this is the world they are living in, I asked an artificial intelligence text-based bot to craft a tribute of wit and words, and here it is, slightly modified by myself. In halls of learning where wisdom gleams, bright minds converge with scholarly dreams. Through endless nights and dawns so fair, they delved into the train's own lair. With diligence that knew no end, they found the curve, the bend, the blend. In steel and steam they sought the art, and each discovery gripped my heart. Their work a beacon in the field, where track and train in harmony yield. In their honor I stand and cheer, for students' brilliance brought me here. To them I raise a heartfelt toast, for in their research I boast and boast. On rails of knowledge they carved a line, a legacy eternal, so true and divine. That goes to the postgrad students. Pausing for a moment at workplace education and short courses, since 1994, the chair in railway engineering developed 16 different short courses and 3 programs. These training interventions are annually presented to Transnet, PRASA, Gautrain and RSR employees, as well as people from government and the private sector. Some of these courses are also written into the individual development programs of engineers and technicians in training. And in most rail engineering offers a thick file entitled Introduction to Multidisciplinary Concepts in Railway Engineering would be standing somewhere on a shelf. The scope and depth of these courses are unique, not only in South Africa, but also internationally. Future plans for training include a variety of blended learning, from face-to-face to online interactive and fully virtual. We have also just completed the development of the Railway Safety Inspector qualification, which will be SAQA accredited and presented to railway safety inspectors in Southern Africa and wider. I'm confident that this qualification will have a substantial impact on rail safety in our country. Finally, I'm coming to probably the most important part of the lecture or address, inspiring a new future for railway engineering in both sectors of passenger rail and freight transport. And here I want to focus on technical matters, followed by more specific aspects related to the future of railways in South Africa. Contemplating data analytics, I've come to the astounding realization that most of the fields I have been working in, namely condition monitoring, vehicle dynamics, subsidence measurement, surveying and track geometry, have been impacted significantly by new technologies. Numerical analysis and big data applications, and these cannot be ignored. To remain at the cutting edge, we are implementing machine learning and neural networks on the foundation of a fundamental understanding of the physics and science underlying railway engineering. And this field is growing at a pace. Previously, we used to walk the track and use basic instruments to measure track geometry, rail profiles, gradients, and track clearances. Today, we have different transportation platforms to take our sensors and measurement equipment on track in our own RRV, on a mechatronic canine called Smoof, and in the air on a drone. These platforms save us time and improve our ability to make fast, informed decisions. Aerial mapping allows us to capture the exact scene of a derailment in 3D with centimeter accuracy from all angles. We have demonstrated in the ease and advantages of such an approach, and we are advocating the mapping of all future incidents and derailments for evidence in the post-event investigations and boards of inquiry. On a smaller scale, we recently measured the time involved in mapping an incident for further investigation. This mock-up at Winelands Light Railway for the International Rail Safety Council was scanned in less than 3 minutes, with detailed point clouds, cross-sections, and scale diagrams available in an hour. Automated raw data reduction and improved computing power in the future will no doubt excel the adoption of this investigation procedure. From a model railway to a full-size test track at Engineering 4.0 on the UP Hillcrest campus. Our dream for the future is a 3.6 kilometer test track that will allow us to experiment on different track components, structures, and even vehicles. The idea is to link this test track with the Prasa railway line between us and the N4 and with the Engineering 4.0 track laboratory, all part of phase 2 of this development. This should be a national facility, granting railroads, universities, and other research organizations access to world-class facilities and track specialists. That brings me to the state of rail in our country. During 2022, SAICI unveiled its most recent infrastructure report card for South Africa. This document rates the condition of all infrastructure in the country and highlights maintenance and other needs in the different sectors. The Rail Asset Group was assigned ratings from A to E. We are therefore faced with an incredible challenge to position and restore rail to its rightful position in the transport sector. Fortunately, we have examples in the country of how a successful railway should be maintained and operated. I'm proud and equally excited about our involvement with the Gautrain Rapid Rail Service. Not only have we been given many opportunities to monitor, measure, and investigate track aspects on the network, our students have also benefited from the research and they were exposed to a world-class operation. We are looking forward to more real-time monitoring projects on Gautrain and the extension of its footprint to a bigger network, linking more households in Gauteng with the economic powerhouse of our country. We have all witnessed the recent destruction of our passenger and freight lines belonging to Prasa and Transnet. But there is much hope in what has been done during the last 2 years to reinstate lines and services across the country. Of 16 priority Prasa lines, 10 have been restored, with the remainder expected to be operational during 2024. Another injection into SA Rail has been the adoption of the National Rail Policy in March 2022. This entails the separation of the Transnet Freight Rail Infrastructure Manager and the train operator, and the commencement of the long-awaited third-party access. This will give similar or smaller private operators access to the national rail network, and for a fee established by an economic rail regulator, they'll be able to run their own trains and grow their own businesses. Short, medium, and long-term goals have been formulated and are being driven and implemented with urgency and support from the highest levels in government. We foresee a greater than ever need to train and educate new entrants to the rail sector, and we therefore prepare ourselves for new opportunities and challenges. On this high note, I'm coming to the end of my address. I've mentioned at the start that my academic career took an unexpected turn during 2023 when I assumed the role of head of department. This is civil engineering, and this is the team that I'm privileged to lead for the next few years. My vision is that we will be known as the most respected and knowledgeable civil engineering department in the country, and that the engineers we train and develop will remain leaders in our industry. I'm committed not towards my own success, but towards the success of each of these staff members. I believe this is how I want to serve and make every day matter. You have indeed graced me with your patience and refrained from leaving the train till this point. Allow me to summarize and conclude with a few thoughts. My tracks of discovery started in the Terra with an appreciation of the rotation of principal stresses as a result of moving wheelloads. Tracks of innovation led me to the development of smart track components, novel measurement techniques, and ultimately full-scale train, track and formation, mapping, measuring and monitoring systems that would contribute to the safe and successful management and operation of a railway. Education for me has been a matter of imparting and inspiring for maximum impact, and nothing gives me more joy to see our students changing the world for the better. I hope and believe that my last thoughts on inspiring a new future for railways in South Africa and abroad have encouraged you, and that you share my optimism for a new chapter and dispensation for railways in our country. And lastly, some words of thanks. I want to acknowledge Transnet for being part of my career from start to, I suspect, the finish line. The last 4 years have been tough, but here's to a new chapter. The Railway Safety Regulator, the National Research Foundation, my UP, and specifically civil engineering colleagues, and my academic supervisors and mentors. Enterprises, University of Pretoria, railway colleagues from industry, students, my family and friends. Specifically to the friends, you know my stories and yet you came again. Thank you so much. A special mention and tribute to my parents, Pietro and Ida Gräbe. From those days in Roosmarijn till today, you have been watching my every step with interest and love. Words fall short. I appreciate, respect, and love you. To my beautiful wife, Dalvanessa, thank you for an incredible journey to this point. Thank you for taking the train with me to many places and for seeing me off at many more stations. You have and still inspire me to see and experience the important things along the track of life. To my 5 children, not here today, Ruan, Leanne-Marie, Ivan, Marlene, Rikus, and can I add, our first expected grandchild. You are giving my life meaning and I love you all so much. To God be the glory. This is all because of His grace. I'm grateful for the financial support we received from the rail industry over the years. Equally important, a number of companies active in the railway sector facilitated track access, donated track components, construction materials and time, and supported our research projects and training. I salute you and encourage you to continue and grow your investment to make our ambitious dreams for the future a reality. I want to thank you all for your attendance, and I want to conclude with these words. Trains are wonderful. To travel by train is to see nature and human beings, towns and churches and rivers, in fact, to see life. This has been my journey to this day, and I've been privileged to see creation, people, towns, churches, and rivers, and much more. Thank you for getting onto this train for a short trip tonight. I will see you tomorrow on the track, or next year at another station, or much later at the final destination. Thank you so much, University of Pretoria, and thank you to you all.
Prof Hannes, it's my privilege to say thank you. And I must say we enjoyed the fact that you showed us that something as simple as a rolling wheel can give rise to beautiful mathematics and engineering. And he fortunately spared us the equations and the details. of which some of us that has been his external examiners for his students had to work through. But it's beautiful to see how all of this actually get together. Also to see how you endeavor to develop technologies to see that which is normally invisible. The different types of sensors, sensor systems and so on. And what's really encouraging in terms of that, and you mentioned it, is the versatility of a lot of these developments, where something like Clippy, which tried to and successfully measured movement of railway ballast, became a smart avocado and a smart tomato. And all of that because the principles of measurement was well understood and developed. And together with that, various of the other technologies, the LiDAR, the LoRaWAN, and a lot of other endeavors that you and your students brought to the department and the faculty that actually became part of our life in various other things. And we do not always remember where it started. So this whole long road that you demonstrated of discovery and improvement, of sensing firstly, and then understanding, then deciding, then acting, steps that we take on an everyday basis in our engineering lives. It's good to see that being demonstrated. And also encouraging to see the continuous focus on making sure that our infrastructure is safe, that it's durable, that it's maintained, and transferring this commitment to a next generation of railway engineers. Because for sure, those of you that are here, we need you guys urgently, and many more like you. And then lastly, and I may be slightly subjective in terms of this, apologies to the other departments in my faculty, but the fact that you show that there are civilized engineers also that understand something about poetry and about the good things in life that we need to eat and drink. It's good to have that part also in the faculty. We really appreciate that. And I want to wish you Godspeed on conducting your future endeavors. We are looking forward and really to a promising further career. I see there's only 30 years gone. There's still a few years to go. I really believe that it will be a very successful journey. With that, ladies and gentlemen, I would like to thank Prof Hannes for the role that she played tonight, being in her position at the end of the year. You become quite busy, and we always appreciate it if you sit in and enjoy our side of campus and the explanations of how the engineering works. Also a special mention to the EBIT team that actually makes this possible, and the guidance of Managa, who's our faculty manager, Suzanne, and Tabu that does the recording. We really appreciate those preparations because that makes this possible. Please continue to be on the lookout for further invitations to inaugural lectures. We've actually got our last one for the faculty next week. And as I always say, also please look at the other faculty's inaugural lectures because we always learn something. Sometimes most of it is confusing, and if the only thing that you learn is that there are good positive careers possible, that's also good. I really want to thank all of you for your attendance and your presence tonight, for the role that each and every one of you play in either Hannes' career or the Department of Civil Engineering as such, because without our family support, without our friends, without our industry support, a lot of these endeavors is just not possible. Thank you very much for that. I would like to invite you now also to, as we are departing, to enjoy some refreshments with us. And with all of that, please stand and remain standing as the short procession leaves the hall. Thank you very much.